Hello everyone. Today I am going to solve a question of Stoke's theorem. Our question goes like this: verify Stoke's theorem for vector field f vector equals to 2y I vector plus 3x j vector minus z square k vector, where s is the upper half of the sphere x square plus y square plus z square equals to 9 and c is its boundary. It means it is given vector f is given as 2y I vector plus 3x j vector minus z square k vector, and s is the upper half of the sphere represented by the equation x square plus uh, y square plus z square equals to 9 and c is its boundary. So now we have solution. Let's move to our solution. Okay, solution. Given function is f vector equals to 2y I vector plus 3x j vector minus z square k vector. Okay, now from Stoke's theorem we know that to verify Stoke's theorem we have to show that line integral of f dot dr vector equals to surface integral s call f vector dot n cap ds. Okay, now let us begin from right hand side. So to begin from left hand side we have to first find out the call f. So as you know that call of vector f equals to nebula cross f vector nebula f equals to we know the value of the nebula. What is nebula? Nebula is the vector differential operator which is used to operate any vector function. Let me repeat once again it. Nebula is a vector differential operator which is used to operate any vector function. Since our f vector is vector function, so in order to operate vector function we use nebula. Okay, so I vector del by del x, the value of nebula is plus j del by del y plus k del by del z cross f vector. Okay, now let us express it in determinant form. We know that I j k vector del by del x del by del y del by del z, and the value of f is along I vector 2y, along j vector 3x, and along k vector minus z square. Solving it we get I vector del by del x minus z square minus del by del y minus z minus del by del z 3x is minus 0 minus j vector. Similarly okay, del by del x partial derivative of minus z square with respect to x minus partial derivative of z partial derivative of 2y with respect to z gives 0 minus 0 plus k vector partial derivative of del by del x times 3x is 3 minus and del by del y partial derivative of 2y with respect to del y is given as 2 equals to 3 minus 2 1 equals to k vector. Before moving ahead, let us draw a upper part of sphere. Okay, so for this let it be x-axis, this side be y-axis. Okay, and this opposite side be x dash, another opposite side may be y dash, and this side be z axis and opposite side be z dash. Okay, since the question has said there is only upper half part of sphere, so our upper half part of sphere is represented like this, and for the upper half part of sphere its projection be for the upper half part of sphere x square plus y square plus z square equals to 9, its projection be like this, which is a circle which lies on the xy plane. Okay, only in xy plane, not in z plane. So x square plus y square equals to 9 and z equals to 0. Let us visualize it. Let us suppose this be a piece of lemon. Let there be a piece of lemon like this, and if we cut it from middle, then the lemon may be divided as upper half and lower half. Okay, so let this be the upper half of the lemon, and if we project, and if we look at this face, we will see one of the circle at the base part of the lemon. Okay, when we cut a single lemon from the middle, then we will see an sphere like this, upper half part of the sphere like this, and in the base part we will see a circle. It means if we project this lemon, then it get reduced to a circle in xy plane. So we have z equals to 0. So from RHS we have uh, surface integral as col f vector n cap ds equals to the value of col f vector is k vector dot and n cap is n cap, and ds can be written as dx dy. Since s equals to, it can be written as k, and since n cap is the outer direction normal to the surface, n cap represents the outer direction normal to the surface. Since the surface is let us suppose this be a lemon, and it is in this paper like this. So let us suppose it as a lemon and let it be in this paper. So its direction is, let it be in the xy plane, so its direction is normal, means normal outer normal, that is its direction is along z axis. So along z axis we gave n cap as k vector dx dy equals to, we can write as dx dy, since the product of k dot k is 1. Let me write down, since n cap equals to k vector. Okay, now we have said that we are going to project this lemon and after projecting this lemon we will get this projection as circle, that is x square plus y square equals to 9, which is the base part of the lemon or the base part of the sphere. So now let r be the projection of the sphere as projection of the sphere. Let r be the projection of the sphere as, so sphere as x square plus y square plus z square equals to 9 on the xy plane. Okay, we are projecting along xy plane. The projection in the projection is the curve. Now the projection is the curve. After projection, what we will get? After projection this lemon, we will get, after projecting this upper surface, we will get a circle. That is, if we project the whole lemon and if you look it from here, then it is a circle. We can find a circle at the base of the upper half part of the lemon or sphere. Okay, the projection is the curve, that is circle x square plus y square equals to 9 and z equals to 0. Now let us find surface integral of col f vector dot n cap ds, which is given by surface integral dx dy, that is n cap ds. After writing surface integral here, we have to use the limit, so we are going to use double limit. Okay, let us look at the figure again. As we know that at the first x-axis will come and after that xy axis will come. Okay, so using the same concept, let us draw a vertical strip. Let us draw a strip along x-axis, that is from here to here. Okay, we get our x varies from at the beginning we only have x terms, no y terms. So at the beginning we only have x terms, not y terms. So y is 0 at this case, so x square equals to 9. We get x equals to plus minus 3, that is x varies from minus 3 to plus 3, that is from minus 3 this point to plus 3. Okay, to in order to cover the whole area, we also need strip along x-axis also. So let this be a strip along x-axis, along y-axis. So to find out the limit for y-axis, we suppose x square plus y square equals to 9, and from here to find y-axis comes after only x-axis. So here we use both variables x-axis and y-axis. So y square equals to 9 minus x square, and y equals to under root plus minus 9 minus x square. So our limit varies from minus root 9 minus x square to plus root 9 minus x square. Using it, we get x equals to minus 3 to x equals to 3, and y equals to minus root 9 minus x square to y equals to root 9 minus x square. Okay, dx dy. At first integration, let us simplify it. We can write it as 4 x equals to 0 to 3 and y equals to 0 to root 9 minus x square dy dx. Let us integrate along dy. We get 4 x equals to 0 to 3 y 0 root 9 minus x square dx equals to 4 times x equals to 0 to 3 root 9 minus x square dx. It is in the form of root a square minus x square, since we have the formula integration along root a square minus x square dx is given by x by 2 root a square minus x square plus a square by 2 sine inverse x by a. Now using the same formula we get 4 integrating it, we get x by 2 means x by 2 will be as it is. A square minus x square means 9 minus x square plus a. The value of a is 3 and a square means 9 by 2 sine inverse x is x and our a is 3. Okay, so using limit, now substituting the values of the limit, we get 4. At first when we substitute the value, we substitute 3. 9 minus 3 square, we get 0 plus 9 by 2 sine inverse 3 by 3 means sine inverse 1. Sine inverse 1 is also sine inverse 1 is first here we get 0 plus 9 by 2 sine inverse putting the value of x3 sine inverse 1 means pi by 2 minus secondly we put 0 at x, 0 dot other term, this term get 0, and substituting here again 0 in the in variable x, we get again 0 plus 0. So we got 4 dot 9 by 2 dot pi by 2 equals to 9 pi. Here the surface S is bounded by now here the surface S is our surface S is bounded by the circle x square plus y square equals to 9, z equals to 0. S is bounded by the circle x square plus y square equals to 9 and z equals to 0. Now to find the line integral after dr, let us solve from the parametric equation. Okay, so the parametric form of the circle is x equals to 3 cos theta, that is we know that the parametric form of circle is x equals to a cos theta and y equals to a sin theta. So y equals to 3 sin theta and z equals to 0. So dx equals to minus 3 sin theta, dy equals to 3 sin theta d theta dy equals to 3 cos theta dot d theta and dz equals to 0. This is the equation of the circle. Okay, let it be the upper half part of the sphere, and in the, if you look from the downward, then we can see the circle at its base. That is the equation of so the circle, for the circle, the theta value of theta varies from theta equals to 0 to theta equals to 2 pi, isn't it? So the value of theta varies from theta equals to 0 to theta equals to 2 pi. Here now we have line integral. F dot dr vector equals to f means 2yi vector plus 3xj vector minus z square k vector dot we know that dr vector is I dx plus j vector dy plus k vector dz. Multiplying it and solving, we get 2y I dot I is 1 and 2y dx, we get 2y dx. Similarly 3x dy minus z square dz. Now using the limit, that is theta equals to 0 to 2 pi, and substituting the value, 2y is 3 sin theta, and the value of dx is minus 3 sin theta dot d theta plus 3, and the value of x is 3 cos theta dot 3 cos theta, and the value of dy is 3 cos theta d theta minus z square dz is 0. So this terms, overall this term get equals to 0, minus 0. Okay, here we get theta equals to 0 to 2 pi minus 18 sin square theta plus 27 cos square theta d theta. Now we know that no integration is done on square form. Okay, so in order to simplify it, we have to change it into double integral formula. Let me repeat it once again. We know that no integration is done on square. Okay, done on square of trigonometric function, so we have to change it using double integral formula. As we know that we have cos square 27 cos square theta d theta minus 18 sin square theta d theta. So we know that from double integral formula, we know that double angle formula, we know that from double angle formula, we know that cos 2 theta equals to 2 cos square theta minus 1. So from here cos square theta can be changed as 1 plus cos 2 theta upon 2. So substituting it, we get theta equals to 0 to 2 pi 27 cos square theta is 1 plus cos 2 theta upon 2 d theta minus we can write, we know that cos 2 theta equals to 1 minus 2 sin square theta, and from here 2 sin square theta equals to 1 minus cos 2 theta, that is, so here we can write 9 times 2 sin square theta d theta, and we can simply change it by theta equals to 0 to 2 pi 27 by 2 1 plus cos 2 theta d theta minus 9 2 sin square theta is 1 minus cos 2 theta d theta. Okay, now integrating it, we get 27 by 2 integrate 1 dot d theta is theta, we get theta plus 27 by 2 integration of cos 2 theta with respect to d theta is it gives sin 2 theta upon 2 minus 9 and 1 into d theta is d theta, so 9 minus 9 theta plus minus plus 9 cos 2 theta, and integration of cos 2 theta is sin 2 theta upon 2, and our limit varies from 0 to 2 pi. Now substituting values, we get 27 by 2 dot 2 pi plus 27 by 4 sine 4 pi minus 9 2 pi plus 9 sine 4 pi upon 2 minus 0, which is equals to 27 pi to get cancel out plus 0, or sine 4 pi is 0, minus 9 to the 18 pi plus sine 4 pi is again 0 minus 0. Here we get 27 pi minus 18 pi equals to 9 pi. So 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 we get line integral of f dot dr equals to surface integral of col f vector dot n cap ds. Hence Stokes theorem is verified. Hence Stokes theorem is verified. Thank you.